Hi everyone, welcome back to another episode. Today we're going to look at Palindrome in NASM. On the right hand side we have the C code for the palindrome, and what I mean by palindrome is a group of words where when written backwards they are the exact same. So for example, the word computer when written backward is RETUPMOC, and it's not the same as this word. But for a word like race car written backwards, which is RACECAR, is a palindrome. The same for madam and the same for Eve. Okay, so on the left hand side we have that for the C code, and essentially let me just try to run it and we see its results. Okay, so save this, I compile this, do palindrome, then I type say Eve, and then we see that it's a palindrome. When I type computer, we see that it's not a palindrome. So that's essentially what we're going to look at today in NASM. So on the left hand side we have the NASM code, and it follows essentially the same structure. So on the left hand side we see that we've defined a couple of things here, the same as in the C. We have the empty message, we have the is not palindrome string, and we have the is palindrome string and their corresponding lengths. Okay, so all of these go under the .data section, and of course we have to append the newline character and the null terminator. Okay, and the next thing we have the char buff, which is uninitialized, so that goes under our .bss section. Okay, and we have int read bytes. Okay, and that also goes, is uninitialized, so it also goes under our .bss section. Then we can begin our code itself. So on the right hand side we see that we're reading from the standard in, that is getting the user's input, and we've already seen that getting the user's input has the following structure, that is 0 goes into RAX, 0 goes into RDI, and so on. And after reading the user's input, we place the value back into read bytes, just as on the right hand side, and then we check whether read bytes is less than or equal to 1, which is the same as less than 2. And if it's less than 2, we're going to print the message saying, we're going to print the empty message, that is input is too short, return 1. So that is in a too few char directive, which you can find here. Okay, so we print the message out, empty message, and we also jump to failure, which is exiting with an error code of 1, just as on the right hand side we have return 1. Okay, then what we do next is we create 2 pointers. So essentially this is how the code looks like. We have the following. So for example, if we type in race car, okay, it enters into buff, and buff has a size of 30. So we're saying all of this is 30. But we see that when we type it into, we're using the read syscall, we're going to end with a newline character because we press the enter key. And so the number or the count of these characters, there are 8 of them. Okay, but when the computer or when we are indexing, we're going to have 0, 1, 2, 3, 4, 5, 6, 7. Okay, and when we want to check whether it is a palindrome, we're going to have to create 2 pointers. The first pointer is pointing to the very first character, and then the end pointer is going to point to the very last character. Okay, but we need to offset. Okay, so once we know the count, which is there are 8 of them, we need to offset it by 2 so that we get to the actual character, which is besides the new line, we have to get the last character, which is going to be 6. Okay, so we have the first pointer pointing to the first character, which is the start pointer, and then the end pointer is going to be offsetted by 2. That is 8 minus 2, which is 6. Okay. So what we're going to do next is we're going to compare the first character with the last character over here. Then we shift the start pointer by 1 and the end pointer by -1. So the next thing we're going to do is compare the index at this point with this one, then this one with this one, then this one with itself, and then we can definitely say that whether or not the word is a palindrome. Okay, so that's essentially what we did here. In the code, we see that we offset the end pointer by 2, then the start pointer points to the very first element's address. Okay, the first element is this and its address. Likewise, the last element is this and its address. And then we do the check-in. So when the start pointer, when we dereference the start pointer and the end pointer, they are not the same, then it means the word is not a palindrome. And when we exit this loop, we see that we can definitely say that the word is a palindrome. So it's the same thing on the left-hand side. And so after reading the value or the read syscall into the read byte variable, then we're saying that I'm just going to place the read byte variable into R8 and then subtract 2. And so we're going to use the R12 to denote the starting pointer and then R15 to denote the ending pointer. So R12 is going to take the address of buff, the very first element's address, and then R15 is going to take that. We're going to offset it by the R8, which has already been subtracted by 2. And then its address is going to be placed into R15. So it's the same thing here. But this time around, we're using the operation called the load effective address. Okay, if we had done move, it would have just written the character in itself, which is not what we want to compare. We want to compare the values at those addresses. Okay, so we have the address of the starting address going to R12, and then the ending address using the layer will be placed into R15. And so essentially we enter the loop now, and in the loop we'll be comparing the two addresses. We're comparing the two addresses, and also if just like the way it is on the left hand side. So in the case where it is greater than, that is the opposite of this operation, it is greater than or equal to, then we know that the word we jumping out, that is done. We're going to print that the string is a palindrome. Otherwise, we continue on with our loop, and we see that we dereference the value at the start pointer and the end pointer. We place them into R13. Because it's a byte and we're placing it into R13, we're going to use the move set x, which is the move 0 extended. It places the byte into R13 and also makes the upper part of the registers 0. The same thing for R14. Then we compare those characters at the start. Dereferencing the start essentially is just this one. So R13 is going to be this one, and then R14 is going to be this one. So it's just comparing the characters, and if it's not equal to, then essentially we say that we print out the string, which is not palindrome, and then we exit success. Okay. And also when we continue on, we see that our start pointer has been incremented. So we increment our start pointer, then we decrement our end pointer. Okay, and the rest follows suit. So this is essentially the while loop over here. And in the case where it's not equal to, we print it's not palindrome, which is this one. And in the case where it is, we complete our loop, then it prints its palindrome, and then it exits success. Yeah, and that's essentially what I want to show you guys today. And also in the case where there are too few bytes, it just prints out the empty message, which is input too short, and then it returns a value of 1. So input too short, then it goes to exit failure with an error code of 1. So let me try running this code. Palin, and let's do hello. We see that it's not a palindrome. And then let's do madam, and then we see that it's a palindrome. So this is what I wanted to show you guys today.